They didn't ship the model, right? They didn't ship a lot of the things that they were, talking about in the 12 days of shipments, right? These were things that were, oh, that will come in January, oh, that will come, early next year.
Hi, I'm Matt Marshall, editor-in-chief of VentureBeat. There's been a lot of buzz around AI in the past year, but OpenAI's O3 model released last week feels like a real breakthrough. Why? Because it tackles one of the biggest hurdles in AI, handling novel tasks. Large language models have long been criticized for doing just what they've been trained to do. But here we have a model that looks to be figuring things out on the fly, which is essential for making real progress toward so-called AGI, or artificial general intelligence. Think about it. The ability to adapt and problem solve in new situations is what makes human intelligence so remarkable. And now, AI is taking steps in that direction. We're diving into Francois Chollet's recent post analyzing the O3 model. Chollet, a well-known skeptic of LLMs' potential for AGI, had previously argued that these models were very limited. Just 6 months ago, he described LLMs as an off-ramp toward AGI, insisting they couldn't handle the kinds of novel tasks needed to reach true general intelligence. But here's the twist. With the O3 model, Chollet's had to make some major concessions. The model has achieved or come very close to the 80% benchmark he himself set as a key indicator of AGI level adaptability. That's a seismic shift, and is exactly why this breakthrough deserves your attention. Now, granted, Chollet has said it's not quite clear whether they've achieved AGI and says it hasn't happened just yet. There's more to do. But in this video, we'll break down what makes O3 different, why its approach matters, and what it all means for the future of AI. Let's start by unpacking the main innovations behind this model using Chollet's analysis as our guide. First, program synthesis for task adaptation. Traditional LLMs have faltered when faced with novel tasks requiring on-the-fly adaptability. They typically memorize, fetch, and apply. They do well at retrieving and executing pre-learned functions, but have a hard time on things they haven't been trained on. The O3 model introduces something called program synthesis, which is what Chollet has advocated for some time. It allows the model to recombine known functions into entirely new solutions, tailored to unseen tasks. This is like a chef creating a brand new dish by combining familiar ingredients in innovative ways. 2. Natural language program search. At the time when O3 goes to answer a question, which is called test time in the industry, O3 performs a search over the space of possible solutions expressed as chains of thought. Think of chains of thought as step-by-step instructions written in natural language, outlining how to solve a specific problem. Guided by an evaluator model, O3 explores numerous potential paths through this space, selecting the most promising sequence of steps. This process is similar to navigating a maze by trying different routes and evaluating their success. 3. The role of the evaluator model. The evaluator model acts as a judge, assessing the quality and accuracy of generated chains of thought. It ensures that the proposed solution aligns with the requirements of the task. This mechanism helps O3 refine its search, discarding solutions that aren't great and zeroing in on effective ones, a method comparable to how chess engines evaluate potential moves before deciding the best strategy. 4. Executing its own programs. In O3, the chains of thought take on a dual purpose. They aren't just steps for solving a program or problem, but also building blocks that the model recombines to tackle entirely new tasks. Essentially, chains of thought act like a toolkit. The model assembles these tools in ways to solve challenges it hadn't encountered before. Over time, these chains of thought become records or artifacts of how knowledge has been pieced together to address unique problems, demonstrating the model's ability to synthesize knowledge dynamically. By generating and executing these chains of thoughts, the model essentially creates its own dynamic programs to address novel challenges. While other approaches such as test-time training or latent space searches are viable, O3's method of natural language program execution represents the current state of the art. 5. Deep learning guided program search. Unlike symbolic programs that interact directly with real-world data, O3's programs are expressed in natural language and evaluated indirectly. This creates limitations, as these evaluations might fail outside of known contexts. Additionally, O3 relies on expert-labeled data to train its evaluator, which restricts its ability to anonymously learn and adapt, a gap compared to systems like AlphaZero that self-learn by interacting with their environment. In conclusion, these advancements not only redefine the boundaries of LLM capabilities, but show continued questions around their limitations and applicability. In the upcoming discussion with Sam Witteveen, we'll delve deeper into the technical innovations behind O3, its broader implications, and what this means for enterprise AI strategies moving forward. Morning, Sam. Merry Christmas. Curious what you think of this breakthrough.
The O3 release was very interesting. Everyone, I think, a lot more people were expecting that they're going to release something like GPT 4.5 or something like that. They haven't actually even launched O3. They've announced it. I think, the end of Jan, they're going to start letting external testers use it. So at the moment, this is a very early, version of the model that they showed. Now, clearly, it seems to be doing, a lot better. But a lot of that comes at what cost? So, like you talked about the Arc AGI, competition and stuff like that. So the competition has been around for a while. The data set's been around for 5 years plus now. And it has certainly been something that for a long time, people really didn't make any progress on. This year, I think they put up a proper sort of prize and stuff like that. So therefore, you actually had people go for it a lot more. I think, the sort of open, they had very strict rules, actually, we should mention about the sort of open entries is that you had to show how you did it. You were limited in the amount of compute that you could use. It had to run offline, so it couldn't be calling, some of these big models. So in many ways, OpenAI has kind of broken a lot of those rules, but they've done so, with the sort of oversight of the people running the Arc Challenge, and have scored two pretty amazing results. So I think the first result is sort of around 75%, with I think it's the O3 Mini or something, basically where they've limited the amount of compute. And then the second result, which is the really impressive one, is this 87% result. And supposedly the cost of that is like 172x of what the lower one got. So we're talking about huge amounts of money just to answer these, I think it's 100 questions from memory. It is interesting that sort of Francois, like you mentioned, was someone who basically said that these models shouldn't be able to, do this kind of thing. And even now he's starting to have to sort of go, wow, this is pretty impressive what they've done. He did point out in that blog post that if you just ensemble all the other entries that are out there, you get to about 84%, meaning that, which is kind of surprising because we would have thought that like each person's sort of entries that have done well, they kind of would have done all well on the same questions and gotten all the other ones wrong similarly. But it turns out that's not the case. Like some approaches seem to do well for some questions and other approaches do well for other questions. So does that mean that OpenAI has just sort of worked out a way of doing, all of these? It is fascinating when you look at some of the answers it got wrong, though, and they're kind of obvious things, right? They're not hugely complicated things. You would expect that if this was really AGI, then we would have, it should have gotten some of these things right. Just remember this is like one data set, one competition. One of the definitions for AGI that I do like is Mustafa Suleiman, who's now head of Microsoft sort of consumer AI. He had something like give it access to the internet and have it make 100 grand, right? And if it can make 100 grand by itself, then it's AGI. And I kind of like that because if you think about it, that's something that would require, going to something like Upwork or some of these freelance platforms, bidding on jobs, being able to complete jobs where they get paid for those jobs and being able to do a whole bunch of that. that would be not just AGI, but that would be a substantial sort of economic shift, right? In that if we had this model that could do something like that, that's going to be a really big deal. If we've got a model that can just do these sort of nice dots on a paper, like the ARC challenge or something, that's going to be great for sort of like an academic thing, but perhaps not going to be a huge thing for business just yet, right? That's the we really want to see what else can the O3 model do that is, that's going to be so impressive.
Yeah, that's something I've been thinking about too, is that the O1 seemed like it was really going into some areas of advanced math, uh, sophisticated scientific problems that it could answer. And O3 feels very much the same way. But I think for a lot of applications, you're wondering, hey, can you just fix some of these basic issues that you're seeing, to your point about, hey, can we have an agent run by one of these LLMs to actually make money through some sort of um, e-commerce or other application, right? And OpenAI had to release something because of all these big developments happening so far, from competitors, right? Google launched something pretty significant with Gemini 2.0 Flash, and flagging what's going to come from 2.0 generally next year. So it had to come up with something by the end of the year, and it had this 12 days of shitless. Is this the significant thing that OpenAI needed to come up with in your view? Or is it just good enough, right? To kind of make sure that the critics don't come out.
Look, the definitely the O3 model sounds impressive, but they didn't ship the model, right? They didn't ship a lot of the things that they were, talking about in the 12 days of shipments, right? These were things that were, oh, that will come in January, oh, that will come, early next year, and kind of thing. Um, it was interesting for me that the 12 days of shipments really focused a lot more on consumer stuff than developer stuff. Definitely the O3 was kind of like the mic drop of last week, mostly because of the ARC challenge, right? I it will be interesting to see, how much better is O3 compared to O1 in terms of, is it just letting it run longer? So we've talked about, that the O1 model, the real sort of change there is you're using a lot more compute at inference time. So when you're actually doing it, it's taking a lot longer to think, right? If the O3 is just taking even more time to do that, and that's what's making it better, then that's going to be really interesting to see, because then we're going to see other players just do the same thing where they will just basically give it, more of this sort of test time compute, inference compute, uh, and be able to get their models to be better. It is really amazing how quickly we've seen follows for, on the O1 models, not from Google. That from Google we would expect it. From Anthropic, I would expect it, even though they haven't released anything yet. But from some of the open source community, we've seen a whole bunch of different things where people are starting to put these ideas out there, especially the Chinese companies, right? The fact that a number of the Chinese companies now have made their own versions of these models really is kind of amazing, and is kind of showing that maybe you can even do some of this stuff without huge amounts of compute.
It felt like there was a lot of commentary on how, this test time search over a space of programs, right? In this case, natural language programs, this space of so-called, the chain of thoughts that describe the steps to solve the task at hand. One of the OpenAI engineers then followed up. O1 was the first large reasoning model, right? It's just an LLM trained with reinforcement learning, right? And O3 is powered by further scaling up of reinforcement learning. Can you put this in context for someone who's not, right? So reinforcement learning, chains of thought, talk a little bit about, is there some thought leadership developing here, or is this stuff that's easily copyable by everybody else?
So first off, you've got what's called chains of thought, right? And this basically came about that people realized that you could get much better results out of these models just by asking it to tell you its thinking. So tell me step by step how to do, such and such. And by telling you the step by step, it turned to stay on sort of the right thoughts that would get a better answer at the end. eventually people started realizing, well, if we trained on these train of thoughts, we can get it to be even better. And that's sort of where we were, this time last year. Then what everyone's been sort of looking at is, okay, well, how do we get it even better still? Is that, okay, now we get it to basically generate lots of answers with different chains of thought, and we see which chains of thought got us to the right answer at the end. And all the ones that didn't get to the right answer, we throw those away. And then we try to work out, well, okay, what were the best chains of thought? So rather than just train it now on getting the right answer at the end, we train it on getting the right chains of thought along the way. And you train a second model that can look at those chains of thought and say, that's a good one, that's a bad one, that's not. And then you use reinforcement learning to basically train that first model to get better at over time at rolling out these good chains of thought. And that's the whole the whole idea. Obviously, the bigger you can scale this, the better. And there are different ways of doing it. So one of the sort of interesting ways that OpenAI had proposed, or that Ilya Sutskever proposed in a paper before he left, was this let's verify step by step, where they would look at each of these steps along the chain of thought and sort of verify them and say, yep, okay, that's a good one. And so you could try and train the thing to go even longer chains of thought, but staying on track as it goes along there. And if you think about it for yourself, it kind of makes sense, right? That if we're thinking about a hard problem, the more we sort of think around the problem and think about the problem in different ways, that often that will help us get to the correct answer. That's what these models are kind of doing, right? In the way that they're doing it. The challenge now with all of these models is not so much the research around it. That certainly the research is going to be a challenging thing, but it's how do you get the model to be able to do inference time? Meaning that, like, as we scale this up and you're suddenly using a lot more compute and inference, how do you do that efficiently so that you can charge people for it without having to charge $20,000 an answer?
These things are moving so quickly. I have had a conversation last night during Christmas dinner with somebody from a large chemical and pharmaceutical company where they've basically decided that they're going to hold off for the next year. They're going to try to hold off from fine tuning any models, building their own models. And this is a company of significant scale, right? At least Fortune 500. The reason is because the models are moving so quickly that they feel that they're going to be burned if they're developing any fine tuned versions off the current models, because then they'll be obsolete after about 6 months or so, right? Because of these new generations that are coming out. So, I'm wanting to tie this back to kind of practical takeaways for our audience, or folks who are building applications in enterprise companies. Is this the conclusion? That, the takeaway is that, hey, they're just going to use RAG, right, to basically call upon data from their organization, anything they have. No, now granted, this person was talking about limited applications, knowledge-based applications, and so on. But just curious what the takeaway is for folks here at the end of the year.
Things have changed, right? The models have gotten so much better now that, and the context for the models have gotten so much bigger that you can just use what we call in-context learning, where you can put the examples in the actual thing that you're sending to the model. Most of the providers now allowing you to cache that on their system, so it's costing you pennies at the most for doing lots of different calls with this kind of thing. The other thing that is really fascinating is that where the fine tuning may come back in is in a different way. Is that with these reasoning models, one of the things that people are starting to see is that, okay, if you really wanted to do thinking for a very specific thing in your company, perhaps drug discovery, something like that, you can kind of get your own team to work out those chains of thought. And then you can do, training on those chains of thought to get the reasoning model to do the thinking in the way that you wanted to do it. Now, the thing that was fascinating about one of the OpenAI, days of shipments was they talked about that they're going to roll this out early next year, and that they're seeing people get, good results with this, with literally just like a dozen examples. So doing the fine tuning with this kind of thing is probably the game is going to change from you needing like thousands of examples for doing fine tuning, down to probably under 100, which is going to mean that the fine tuning is probably not going to cost you that much. It may be, it may make sense for doing that kind of thing where you basically just say, right, we're going to fine tune the latest O3 model for our specific type of thinking for really unique things. And for everything else that we're going to use RAG and stuff like that, we're just going to basically use whatever models off the shelf that's a good sort of cost trade-off and stuff like that. The crazy thing is that the cheapest low-level models that are out there now, the Gemini Flash model, the Claude Haiku model, the even the OpenAI mini models and stuff like that, these are way better than what we had 18 months ago, right? Yeah, and yet now they're just like, really super cheap models where people can just throw, millions of tokens at them and it doesn't really, cost you much at all. I think we're seeing a change going on in where the value in the stack is, right? And I think this is really important to a lot of things we talk about, for sort of business users and stuff like that. People can do pretty good jobs with the models that are out there that are really cheap now. So now the game is shifting from sort of the model layer to the sort of layers above that. And that's why we're seeing such, where everyone's so hot about agents, right? Everyone's, talking agents this, agents that, I and and really what they're saying is how do we build really cool apps on this foundation layer? Now that this foundation layer is pretty solid and is pretty good, and we don't have to worry about it hallucinating every response we get or things like that. The models are getting a lot better at those things. Maybe not perfect, but they're getting a lot better. I we're now starting to see people go, okay, now how do we use this to make money, right? How do we use this to actually build a product that's useful to people?
So ultimately, these things are just good enough, right? So even if there wasn't an advancement, and I think there's a need for it sounds like there's a need for the labs, each of them, right? Whether it's OpenAI or Anthropic or others, Google, to say they're ahead, obviously, right? For positioning, and then to keep making these advancements. You're essentially, it feels like you're saying, hey, it's good enough. Now it's, there's all these things on top of the model that we're going to be building, and you're confident that we've got enough to really have a great year in 2025 to do some amazing applications, right? Without further
For
advancements
sure.
on the LLM
Yeah,
side.
for sure. And the thing is, any advancements that we get from the LMs just make this whole thing even better. But the fact that they're sort of like planting flags is showing where these things are going to go. And it's going to come down to now, like, okay, developers working out how to actually plug all this together, how to sort of get the just key decision points, how to refine the LLM to actually make that decision point. And now it comes down to each person in their industry to work out, okay, how do we do that for our industry? How do we make how do we get something like that so that we can sort of capture as much of the market as quickly as possible?
So wow, so 2025 is going to be a fascinating year, Sam. And then and like you said, and then everything is gravy on top from what the LLM providers can give us, right? And I was listening to Dario Amade, CEO of Anthropic's conversation recently, where he was talking about, he was assuming AGI is coming. I think he was saying this around 2026 or 2027, or some of the bigger advancements, right? Of course, there's a lot of risks that it won't happen. There's things that could delay it, but it's just fascinating that we have all this value that we can create as soon as next year, even if everything stopped. But then just these massive opportunities that could potentially keep opening up over 2026 and 27. So really looking forward to seeing what happens next year. And then, you and I can talk about how to plan for next year.